Well, hello, everyone. Thank you for joining us. I hope you had a wonderful day and a nice long weekend before you returned and came back to school. It's always nice to have that Labor Day weekend, right, Heather?
Yes.
Beautiful. Wow. Welcome to Dare to Differ. We are going to be talking about differentiating your students' programming experience with LEGO education. So I appreciate you joining us. My name is Colleen Cannon-Ruffo. I am a solution architect with LEGO Education. What that means is that I work with my account managers. Two of them are here today, Stephen Weniger and Kristen Bettiger. And I work with my account managers to make sure that the solutions that we put into the schools and the districts that we are working with really match the curricular vision and goals of those schools and those districts. So I'm very excited about being here with you today and just having that ability to kind of share with you what we are and who we are and what we do. So when we talk about differentiate, we want to say, why should we differentiate, right? What's the purpose behind it? I like to start with this picture. It kind of shows what many people still have in mind, what they think about school. It shows us a group of young people who all look the same, who are probably around the same age, and then you have the teacher at the front of the classroom delivering their instruction. This scenario wasn't very different in previous decades or even centuries, but because of television and the internet and modern methods of communication, today's children in most parts of the world are dealing with knowledge and skills in ways that are very different from the ways in which their parents learned. And yet, in many classrooms, you will still see this happening, and we are still teaching students in the same ways that their parents were taught, right? I like this second picture. It kind of gives us a better view of what students are really like or how we should see them. While all these students may be around the same age, they are all individuals and they bring their own unique talents and interests and dreams and skills and thoughts into our classrooms. Our students are as academically diverse as they are in size, personality, and interests. So our job as teachers is simply to help each student get as much as possible out of their potential. Carol Ann Tomlinson says in her book, How to Differentiate Instruction in Academically Diverse Classrooms, differentiation is about maximizing the capacity of the children in our care. It's about optimizing their learning experience so we can make sure that the educational experience they get really is the best possible experience. So how do we shift from a one-size-fits-all approach to a more differentiated approach that fits the academically diverse classroom that we're teaching it? According to Tomlinson, differentiated instruction puts students' diverse needs front and center, right? It allows us to see our classrooms as academically diverse ecosystems where the teacher uses a designer mindset to adjust specific instructional elements to the needs and interests of the students in her classroom. It's about creating multiple pathways to the learning, from how they acquire the content that we want them to learn, to how they process or make sense of that content, and finally, to how they demonstrate and show us what they have learned. These pathways to learning need to fit how varied the students are in front of us, their readiness for learning, their interests or their passions, or their unique backgrounds that they're bringing into that learning process. Tomlinson did a really nice job of talking about what is differentiated instruction and what differentiated instruction isn't. I thought we'd start with the what it isn't. It is not individualized instruction. We cannot be creating a lesson plan for every single student in our classroom. We don't have time for that. Teachers have enough on their plates as it is, right? So it's definitely not that individualized instruction. It's also not chaotic. I know a lot of teachers worry about differentiation when they're doing different things in the classroom because they're worried they're going to lose control of that classroom. But it's actually the opposite. When we are differentiating instruction for students, they become more productive and more focused in the classroom. We find that when students are engaged, their behaviors are better. So it becomes a more productive classroom overall. It's more about orderly flexibility than it is chaos. It's not another way to provide for homogeneous groupings. We are all familiar with the blue, red, and green groups, right, that you got assigned to in your elementary classrooms and then never moved out of at any point during your education. We don't want that happening. We want these to be flexible groupings, right? And it's not just for outliers. Differentiated instruction is not for the top students who are strong in what they're learning and maybe able to think critically and problem solve more easily than others. And it's not for the students at the bottom who are struggling with their learning, who need scaffolding in order to be more supportive, right? It's for everyone, including those students in the middle who often get left out in those scenarios. So let's talk about what it is. Differentiation is proactive. It's when this teacher is looking at the learning and setting up those different pathways in order to provide a variety of ways for students to get at and express their learning. It's more qualitative than it is quantitative. It's not just about adding more assignments on more and more in order for those students who are done with this to be able to keep learning, right? It's more about the types of things that they're doing in the classroom, the nature of the assignments that they're working on. It's about taking those multiple approaches to the content, the process, and the product. It's about making this experience student-centered. So why should we differentiate when it comes to programming? Well, that goes back to Tomlinson's quote. Differentiation is about maximizing the capacity of each child in our care, right? We need to differentiate learning in computer science in the same way that we're differentiating learning in math and ELA and science, right? Students are coming to us with varying levels of ability and varying levels of readiness. I need to tell you the story of the third grader who taught me Python. So I had a third grader as a technology integration specialist who came up to me and said, Mrs. Ruffo, it's time for us to start learning Python. And my question to him was, well, what is it? Because I wasn't familiar with Python at that time. That's when the third grader took the Raspberry Pis that we'd purchased and helped me set them up and then showed me how I could start programming in Python and changing the code within the games. What I remember from this experience is that here was this student who knew what text-based coding was, who had access to someone who taught him about text-based coding, and then was able to share what he had learned. And all I could think about was how many other students in this class would have been able to do the same thing if they had ever been provided that level of access, right? That's why we need to differentiate when it comes to programming, because some of these kids are already there. They're doing these things outside of our classrooms. And some of these kids would be ready for it if we were to give them those opportunities. They just don't know it. And I think that's a large part of the reason why we need to talk about differentiation in computer science. I think it's very easy for us to focus on how we differentiate in the other subjects, but we need to differentiate in computer science as well. State of flow is an essential part of our LEGO education approach to learning. Flow is considered to be a state of mind, essentially. You're in flow when you are committed, engaged, and concentrating, so much so that you don't notice what's going on around you, right? This is different from zoning out when you're in front of your binge watching television. It's that idea that you are just so absorbed in what you're learning that you can't see anything else. The challenges that we set for students need to be open-ended and flexible enough that students aren't under-challenged and bored or over-challenged and frustrated. So that leaves us in the middle, that optimal level of challenge that gets students into that state of flow that makes it easier for them to learn. LEGO Education does a beautiful job about when we're designing our resources to allow for that optimized state of flow for our students. So how do we shift from a one-size-fits-all approach to a differentiated approach that fits these academically diverse classrooms that we're teaching in? That you start with a product like ours. You start with LEGO Education. This is where I look at our learning system and how beautifully it can be used to differentiate learning in the classroom. Our learning system starts in the early learning area, right? In the story with kindergarten and pre-kindergarten, with our solutions of Story Tales, Coding Express, and STEAM Park. From there, it moves into the primary level with Spike Essential and Brick Motion Essential, those two that are in the green in the middle. And then from there, it moves into our secondary level, 6, 8, and beyond, I like to say, into the Spike Prime and the Brick Motion Prime. The solutions above the line are what we consider our digital solutions: Coding Express, Spike Essential, and Spike Prime. Those are the ones that I'm going to focus on today and kind of talk our way through. The components of our learning system are these 5, right? They start with the units and the lesson plans. Those units and lesson plans have been developed to be appropriate to each of those various grade levels, and they'll grow with the students. The blocks are the same. We have the Lego bricks, and those Lego bricks start with the Duplo blocks at the earlier learning. They move from the Duplo to the system bricks in the elementary classroom, and then from there into the secondary classroom with the Technic bricks, which allow for more sophisticated programming and modeling, basically. Programming is the next component within our system, and this programming piece is where I really see our chances for shining, for differentiation. It starts with the physical computing in Coding Express. It moves to the block-based coding with icon blocks, and then from there into the block-based coding with word blocks. And finally, directly within that same app, into text-based coding with Python, solving that problem for that student, that 3rd grade student who came to me so many years ago, asking where was it. We also have intelligent hardware that grows along with the students, starting with our little train that they can program to recognize the action bricks on the track, moving into the hubs, the hub that has an input-output port, and then it has the motors and the sensors that go along with it. That hub becomes bigger at the Spike Prime level, where they now have 6 input-output ports, and then they have all the various motors and sensors that go there too. All of this includes the professional learning that goes along with it, that really helps our teachers internalize what we need them to learn. So what does differentiation look like in that learning system, right? This is a quick little video I'm going to play for you. I'm not going to play the whole thing, but I wanted you to see a model that a student would build, and then the program that the student would create behind that model, right? They do a beautiful job of kind of illustrating for us that this is the fast lane. This is a story in which Leo has to figure out how he can enter this amusement park, but there's a super long line, and we don't want to wait in that super long line. But Leo has the fast pass, so he doesn't have to. So he takes that yellow ticket and he shows it to the color sensor, and the color sensor turns green and lets him straight through with the fast pass, right? And then the students will program that model. They'll build the model first, and then they'll program the model to do all of that. Let's take a look at what that looks like within the learning system. Differentiation starts with the story. All of the stories at Spike Essential are, all of the lessons in Spike Essential are story-based. So the students are introduced to the problem through a story. And you'll notice that right within that story is a little speaker icon. That's so that this can be read aloud to those students who are struggling with their reading, who are still emerging readers. If I move to the next screen, you'll see that we can also change the language in these to any of 23 different languages. So we're differentiating for those different learners in our classroom who are not English speaking, right? And who are still English learning. That ability to switch between language, I think, is an incredible example of how you can differentiate right within the lessons themselves. We design our lessons using an instructional strategy for computer science lesson design called Use, Modify, Create. So when the student finishes building the model, the next thing that we ask them to do is build the code. They're actually going to be guided to do so. And you can see this is the piece of code that the students are given to build to let Leo enter the fast lane and get with his yellow ticket and get that little green light to shine. So this is the code that all of the students will build to begin with. Notice on the bottom, there's not many coding blocks on that menu palette, right? So we're trying to get them focused on what we want them to learn, and they're going to grab what they need as they need it. The second step in the lesson then says, and asks them to basically have that yellow ticket react in a different way. So now the students are given a little bit more on the bottom in that menu palette to choose from. And then they can say, okay, well, I'm going to have it not only show the color green, but I'm also going to have it play a sound at the same time. Or I'm going to have it graph the colors so that I can see how many yellow tickets have been collected. So in this way, we're starting to build out on what the students know and how they can program this model. Notice on the bottom, they have a little bit more to choose from, right? We're expanding what they have to program with as they get further into the lesson so that they're not overwhelmed or distracted in the beginning. For most students, you could leave, if this is enough, you could have the students just programming with that one program string. But you could also start walking around the classroom and prompt other students who might be ready to do some other things with that code. As they move to the next step in the lesson, it opens up even more code along the bottom in the palette, and the students can choose to do more things with that code, right? This is the beauty of the fact that our lessons are designed in a way for students to move through them at their own pace, as opposed to being led through the lesson by the teacher. So as they're moving through their own pace, that natural form of differentiation is already happening. And a teacher can turn to one group of students and say, hey, why don't you see if you can get it to react differently to different colors? Whereas another group, she might just have them play a little bit more with that first color that they're working with. So in that way, we're kind of naturally differentiating for the students, which is awesome. But I get excited when we can go to that next step, which is if you've got a group of kids who are ready for it, how do we get them to move from icon blocks to word blocks? How can we take them to that next level of learning, right? It's a simple matter of clicking new project, word blocks, and create. And now they get another palette, and from that palette they can start to create this same program with word blocks, not just icon blocks. This is where I get excited, asking the students, hey, you've already created this with icon blocks. Do you think you could do the same thing using word blocks? What do you notice when you see those two programs on the right? I'm going to ask you guys to take a look at that. The icon blocks on the top and then the word blocks on the bottom. What jumps out at you? What do you notice? You can go ahead and pop that in the chat. I'll give you a second to look. You're right, Lisa. It's exactly what I was going for. It's the colors, right? The colors match. And I think that's where we get really excited with kids. The fact that we can take a look at the colors of what's happening within that code and then kind of start to match them up. I'm going to show you a resource here. That code starts with an event block, right? That event block says play, anything that comes after this block. That icon block, when you look over to the right, has a similar play block that is called when program starts in word block coding. They look very similar. They're the same color. All event blocks have the same color. So having students and getting them focused on the colors to start with lets them then kind of play around with whatever blocks they see within that color palette. And then from there, they can look at the images and they'll see how those images start to match. And from there, they can start actually programming that program in word block based coding. Here's another example where they're given the light blocks, right? In the icon block based coding, they use a 3x3 light block and they use the drop down to change the color. When they get to the next part of the code, they have to say how long they want that color to be on, right? For 1 second. In word blocks, they actually get two different versions of that. So they can either choose a block that just has it turn on, or they can have a block that has it turn on for 2 seconds. That'd be really interesting to see what happens if they use the wrong block. And that's part of what I love about this approach, right? Helping students transition from icon blocks to word blocks. Coding isn't just about becoming a computer scientist, about being a programmer. Coding is all about problem solving. It's about using your critical thinking skills. communicating and collaborating with your partner to say, which one do you think we should use? And why do you think it did what it did, right? And it's that idea of problem solving behind it that I think is amazing for our students. It really gets them thinking and thinking deeply. What they'll find is if they use the wrong one, if they just turn it on and then they turn it off, they'll never even see it turn on because the flow of that action is so fast, nothing happens. They'll discover they have to use the one that has turn on for 2 seconds in order for it to match what they had in their icon block-based code. The thinking behind this, the problem solving that can go on if we say to them, hey, challenge yourself to get to that next level. I also think about it from the backwards perspective though, too, right? If I have a student who's struggling with reading, and I've put all these traditional manners of reading in front of that student, and they're still struggling with reading. What if I gave them something to play with, right? So that they could learn through play. And I ask them to do the same things with icon blocks and word blocks. Will that start to get them to make some connections in literacy that they might not have made? I think that could be really interesting as well. I never like to say someone can't do something. I like to put it in front of them and see what they can do with it. And it's always amazing what students will do. Here's just another example of how you could differentiate using our program, right? This is our taxi model. So the students are building this model. At this point, we're in word blocks. So we're already using word blocks for what we're doing. And the code that they're given there is on the left. And basically, the students will learn how to get this model to move forward, and then it'll turn right, and it'll be basically a 90-degree turn. That's all they need to be successful with the task, which is to get it to go through that path to get to its destination, right? We're trying to get Leo to the museum. So the students are being challenged to build something like this, where it gets them to move forward, turn right, move forward again, turn left, move forward again. They're at their destination. And that's awesome. The kids are going to play with the different parameters within this code, and they're going to learn what we need them to learn. Again, they have what's needed on the left-hand side for them to be successful with that task. But what if you said to the student who is ready for it, or who has finished that and needs something else to challenge them, say, what is it that you could do to get this taxi to go around the block, right? What kind of a shape does a block in a city make? Is it a square? Is it a rectangle? What are the attributes of that square? What are the attributes of that rectangle? And now you can get them to start thinking about how they might code that. And then they might start thinking about how they're going to use the loops to make an action that repeats happen more than once, right? So you're asking them by way of the challenge to do something a little bit more robust, a little bit more rigorous. But even better is if you say, well, what challenge can you come up with? And I think about the classroom where kids were building robots that could move exactly like this, moving forward, moving backwards, making turns. And the kids said to me when they were done with my challenge, well, could we get it to leave the classroom? I'm like, well, that's a good question. Let's see if we can. And they programmed the robot to leave the classroom. And then said, well, can we get that robot to travel around the library? And of course, that's what they got it to do. And then they said, well, can we get it to leave the classroom, go around the library to the principal's office, and then back up and knock on the principal's door 3 times? And did they accomplish that? Yes, they did. That's exciting. When the kids start really differentiating for themselves, the agency that comes on board at that point is just phenomenal, because that's when learning goes really deep, when they retain what they're going to learn because they're so excited about the challenges they've set in front of them. So hopefully you've seen that we've built some differentiation into the lesson already through the design of our lessons. But in addition to what we've done within our app and within our lessons, we also at LEGO Education are always striving to develop new resources to help our students. This is one that one of my amazing colleagues, Dr. Leanna Prater, developed. It's a resource that helps teachers transition students from icon to word blocks so that they can see what the equivalent structures are between those 2 programming languages. Not all teachers who are doing coding in the classroom with students have a computer science background. So resources like this really help to build capacity in our teachers and confidence for them as well. So it's an awesome little resource that we can share with you if you're interested. That's all exciting. Then we can take the next step. how do we get them from block-based coding to text-based coding? Because that's all possible within this same app as well. And I think that's one of the things I want to stress is that this is a learning system. That learning system can do everything from that icon block-based code to the word block-based code, and now hopping into Python with text-based coding. This is an example of a lesson, a little bit more robust robot that we're building than the taxi model, right? And in this one, this is a middle school build, middle school, high school. Essentially, what they're going to learn how to do is get this robot to move forward and backwards, and then how to get it to turn 90 degrees. But this time they're going to be using the gyro sensor in the hub so that they can use angles when they're making those turns with their robots. Notice, just like before, we have the use, modify, create lesson design strategy that we're using so that students are given the code that we want them to learn from. Then they start modifying this code, learning what it is that we want them to learn. We've limited the palette of blocks that they have available to them so that they aren't distracted or overwhelmed, and they're really learning what we need them to learn. I like how in the lesson we've used the comment codes so that they can learn what each piece of this program string can do by the lesson, just reading those comment codes, right? But at this point, now we can get the students to take a look at that same behavior, and those students who are ready to make that jump to the next level can program that same thing, that same model, using text-based coding with Python, right? So the best part about it is everybody's still building the same model. Everybody's still doing the same type of activity. They're getting to their learning. They're demonstrating that learning in a way that is appropriate for them, right? Whether they're ready for that text-based coding or not, but they can all still be participating. And I think that's the part that I love. Just like before, it's just as simple as click new project, select Python this time, click create. And then you're into the Python API. I do believe that the Python API may be one of the best kept secrets that we have in LEGO Education. A lot of people don't even know it's there. This is what that interface looks like. The students will be putting the code on the left-hand side. They'll be typing or copying and pasting on the left-hand side. And on the right-hand side, they have the knowledge base. The knowledge base is one of my favorite resources that we have here. There's two components to the knowledge base. There's the getting started knowledge base and the API modules. I'm going to take a look at those getting started knowledge base. And what you see over here on the left-hand side, I'm going to pop out of here for a second. What you see is an animation that did not work for me. I'm going to stop my share for 1 second and see if I can't fix that for us, so that it actually works the way it's intended to. Give me 1 second. There we go. Now it does what we need it to do. And I'll pop back into what that looks like. So here's your getting started menu, right? What we're going to ask the students to do is look at that menu of options and what is it that they think they're going to need in order to accomplish those behaviors that we just did with the robot, getting it to go forward, getting it to turn. And hopefully what they're going to notice is that it's the controlling motors section that we want them to go into. When they go into that controlling motors knowledge base, what they're going to learn about is how to control the motors using the code that you see below. In that
Colleen,
code, yes.
sorry, I don't think you're sharing at the moment.
Oh, thank you so much. I appreciate it. I knew I missed something. Let me see if I can get back up. Thank you. Now can we see?
Yes, you're good.
Beautiful. Thank you, Mike. I appreciate that. So what you see over here on the right-hand side are the getting started modules, right? The students just completed the training camp 1 where they got that robot to move forward and turn and control that using the word blocks. Now I want them to come into the getting started and I ask them, what is it you think you need to do here? Which one do you think is going to help you learn what you need to learn? From there, hopefully they'll choose that controlling motors section, right? That's the one that we want them to go into. In that controlling motors section of the knowledge base, they're going to learn about how they can control their motors. Inside the knowledge base, they're given these little snippets of code, and they can use that little double copy icon on the right-hand side to copy that code and paste it into the code editor and then press play. Just like before with the use, modify, create, we've given them the code that we want them to use. They will have success with it, and now we're going to ask them to start modifying that code. As they progress within that getting started module, it gets progressively more complex. Now it's going to give them a little bit of information about doing this with multiple motors instead of with just one motor, right? So they can copy and paste that code, put it in and see what that does, start modifying, start remixing. And then finally, it'll give them one more task that they want them to do. So in this one module, they're learning how to control one motor, how to control two motors concurrently, and then how to control two motors asynchronously. And all they had to do to learn this is click that little copy button, that little icon, paste it into the code editor and observe what was happening, and then start modifying and remixing what they're going to learn. In this way, you can learn how to use the Python code that you just programmed in word blocks. I think it's amazing that all of this is built directly into that API. It's one of the things that the engineers in Billund were in Denmark are so excited about, the fact that that knowledge base is built right into the API to get the kids started. But that's not the only resource that we have for them to use. We've also taken every single one of those lessons, those Spike Prime lessons that we have, and we've built the initial piece of code that we give them in word blocks so that we could give it to them in Python as well. So that's what this document is. It has every single one of our lessons, and every single one of those lessons has code that's associated with it, so that they can take that code, paste it in, use it, play with it, modify, remix it, and learn from that experience in the same way that we ask them to do that using the word blocks. This is where I get excited about that differentiated classroom. There's no reason why we can't say to students, here you go. We are going to be working on training camp 1. Which way would you like to approach this problem? Would you like to use the word blocks and learn this way, or would you like to use the text-based coding with Python and learn in a different way? And again, it goes to that idea of how do we create those multiple pathways for our students to learn what we want them to learn, and then to show what it is that they're learning, that product that they're going to produce from it. If this isn't enough, you have units and lesson plans that have been written as well. So that can take you to that next step and basically say, you know what, now that I've figured out how to move with motors, I want to get more precise with that. I'm going to do one of these lessons that's about getting moving with motors, and then learn even more. Those units and lesson plans can be combined, and we actually have Python courses. We have Python 1 and Python 2. I'm hoping that you've seen that our app and our lessons that we have designed have the ability to differentiate in so many different ways for your students, whether it's through scaffolding that's built within the program, or by creating those abilities for them to transition from one type of coding language to the next. If we are able to follow that, what you'll find is something like this. I like to call this the low floor, high ceiling, wide walls. With Lego education, it's a low floor. Kids get excited when you walk into a classroom with Lego. They know it. It's something they're familiar with. It's something they love. That low floor lets us go to incredible places. We have built all kinds of lessons with very high ceilings, so that students can go as deep into the code as we want them to go. But more importantly are the wide walls, right? If we get out of their way and let them learn in the way they want to learn, and let them design the problems that they want to solve, it's amazing where kids will go. And that's where I get very excited about how differentiation can happen with Lego education in the classroom. With that, I'm going to open it to questions and see if anyone has anything they would like to ask. Oh, thank you, Vanessa. I'm excited about it too. I think there's some amazing things that we can be doing with students in the classroom. Do we have any specific questions based on what you've seen? You show how to get the Python versions of the lesson. Yep, let me stop sharing on this one. And what I'll do is I'll end my slideshow and I'll take you live. So and I'll pop back in. This time I'll try and share instead of talking as if I weren't. You. All right. I'm going to ask if you can see my screen. Is it there? Beautiful. All right. So I'm going to start by the lessons. You had asked about the lessons. If I go to if I go to education.lego.com, that brings me to this Lego Education website, right? And I'll pop on here for a second. There we go. My computer's just a little bit behind. So education.lego.com, you land here, right? If I come up here to the right-hand corner, you are going to see something that says teacher resources. I'm going to go ahead and click into teacher resources. And on teacher resources, one of the first options you have in the middle here is called Explore Lessons. So I can click on this Explore Lessons and it will bring me to a database of every single lesson that we have in LEGO Education, from our current products to our retired products. So if you look over here on the left-hand side, when I click on that drop down, you are seeing this, aren't you? Okay, I lost my box around the screen. Just want to make sure. When I click on products on the left-hand side, I can go over here to Spike Prime. That will show me all the Spike Prime lessons that are based on word blocks. Or I can click on Spike Prime with Python, and that will show me all of the lessons that are based on Python. So that's where I can get to the units and the lessons. I can click into any one of these units, and then from here, I can get directly into those lessons. And they will walk me step by step through the 5 E's framework to teaching that lesson. So all of those are there for you. When you are in LEGO Education, Spike Prime, I can go here to spike.legoeducation.com. When you are in the app itself, whether the web-based version or the regular version, in order to get into the Python API, you need to be in Spike Prime. Even though you can enter in through Spike Essential and Spike Prime, you need to be in the Spike Prime side of this. And then when I come over here to New Project, I click New Project, Python, Create, and I will be in the Python API. And that's where you can find the Getting Started modules that I was referencing earlier. And the Controlling Motors one was the one that I was showing. So it gives you that code, you click paste, you click copy, and then you come over here and you highlight and get rid of everything that's already there. Whoops, sorry about that. And paste. And you can begin to play with the code just like that. And you'll notice that each of these sections in the knowledge base ends with a challenge. Can you change the code to run both motors at the same time? I love getting started with this. This is a simple little hello world. Everyone's done hello world in some way, shape, or form, right? If you're in computer science, click on that copy, click on paste, and then start learning how you can change the light matrix to say what it is that you want to say. You can even have it greet you, which is what the challenge is at the back, right? So can you change the code so the hub greets you? One of the things I love about these too is there's a lot of awesome information about computer science in here. How to define a function, what a function is, how you add parameters to those functions. There's amazing information that the students will find just in the knowledge base. That's not even in the lessons themselves. So that's how you would find both of those resources. In terms of the Spike Prime, we can definitely send a link to this document that I was referencing that has all of the code for all of our different lessons in it, right? So that they can always start with that code and then begin to modify and make changes and then create from there. This is how I've taught myself Python. So I've been going through each of these lessons and applying these pieces of code and then going into the knowledge base to figure out how I want to kind of customize it from there. I think I see some things in the chat. It's definitely motivating for students. Yes, it would be the same on the iPad app. If you're asking about Python on the iPad app, it's a little harder to delete all of that code that's in there. It's a lot easier to do it on a device, a Windows device, a Mac device, or a Chromebook. All right. Are there any other questions? Awesome. Well, I will stick around if there's any questions. But other than that, that's kind of what we wanted to share with you, talking about differentiation, talking about how it's built into our product, and then how you can use those various elements to customize for students.